Hello everyone. In today's technical session, we are going to talk about the boost converter, which is also known as a DC to DC step-up circuit. The circuit which increases the output voltage with respect to input. So this circuit consists of one battery. So we can name this as a V in, one inductor in series with the battery, that is L, then a diode which is again in the series of the inductor, that is D, and at the output section you can see the capacitor across the voltmeter, okay, for filtering the output, and parallel to the battery there is one switch over here, okay. So in the boost converter, what happens, as the output voltage is increased, the current is also decreased over here. So if the circuit is having the 100% of efficiency, you can say the total power of input and output is always will be same over here, but practically it is not possible over here. Output power is decreased little bit due to certain losses over here. Now in this circuitry, the inductor plays the key role. So let us see how. So this circuitry is divided in two parts. In the first part over here, we can say this as a switch S. So when the switch S is equals to closed, okay, so first we'll close the switch S over here. So if I close the switch S, there will be the flow of current, okay, so there will be the flow of current I through the inductor L. As this switch is short circuit, it will go through the switch and then it will come back to the battery. So as the switch at present it is a short circuit, there will be no flow of charge energy is going to flow through the diode towards the capacitor and output. So it will be flowing through the inductor itself. So what happens here? So when the switch S is closed over here at the inductor, the current I goes on increasing. As the current goes on increasing, the magnetic field across the inductor also goes on increasing. Thus, the energy across the inductor also increases over here. With the polarity plus at the input and at the output it is minus over here, okay. So this is during when the switch S is closed over here, okay. Now in the second part, let us see the switch S is open, okay. So let us open the switch S over here. So now the switch S is open. Now when the switch S is open, there is a flow of charge. There is flow of charge through the inductor, through the diode towards the capacitor and the output. Now when the switch S is open, as there is a flow of charge through the diode, the current across the inductor starts collapsing. Hence the magnetic field also starts collapsing, which is again converted into the charge, and this energy also goes on collapsing. So according to the Lane's law, when there is a change, or we can say when the magnetic field is getting collapsed, there is also the change in the polarity. Now the polarity will become minus and the plus. If I show here in the circuitry, this will become minus and this will become plus over here. So now if you observe, the inductor now will work as one of the battery. We can say this is B of L. So inductor is also working as a one of the source, and already the battery is the one of the source. And if you see, the polarity is minus plus minus plus. So there are two batteries in the series. So the amount of voltage which we are going to get at the output will also increase. So there are two batteries in the series over here. Therefore, what happens over here? The V0 at the output is greater because of the sum of the voltage, that is because of the input of the battery plus the voltage across the inductor. So these two voltages get added, which we are getting at the output, and hence from this we come to know that the output voltage goes on increasing. So this is how the output voltage goes on increasing. Okay, now the another fact, then what is the role of the diode over here? Now if I assume the input V in is equals to 10 volt and a capacitor storage is up to the 50 volt over here. So as a large amount of charge is going to flow from here because of these two battery, it will start charging the capacitor, and the moment will come when a capacitor voltage is going to be greater than the input voltage. Okay, now in this case what will happen if the diode is not present over here? Assume this is a short circuit over here. So if the capacitor voltage goes on increasing, it will start flow of the charge from the capacitor back to the input side over here because of the maximum voltage is charged across the capacitor. So in this case what happens, the diode present over here, it becomes a reverse bias for the charge of the capacitor, and maximum charge from the capacitor you will get at the output. Hence the output voltage goes on increasing. Another fact is that the output voltage goes on increasing, but how the current goes on decreasing. So my dear friend, we can see that when the capacitor, when the switch S is open, the maximum there is a flow of charge at the output. But when a switch S is short over here, when it is closed, totally closed over here, there is a flow of current through the inductor towards, again it is passing through the current. So the maximum current is flowing from here switch and during as the switch is closed over here. So at the output you won't find over here, and because of these the output current also goes on decreasing. So if you take the average current at the output during both the cycle, that is when the switch open and close, you will find that the current is decreased over here. Okay, now another fact one we should know, the voltage across the inductor, that is a V of L, is equals to L with respect to the time, di upon dt. It is because of the time. Okay, so that time is nothing but the opening and closing of the switch. Now suppose this switch is replaced by any MOSFET or any FET, and that has been connected to any 555 circuitry which is closing on and off of the switch continuously. Okay, so that the voltage across the inductor is nothing because of product of L, that is the capacity of the inductor, into di upon dt. So from this equation we can straightforward say that as the inductor increases, the voltage also increase over here. And as we can see that if the switching frequency also increase, so if we can say that the switching frequency F is also increased, here the di upon dt, the time also goes on increasing over here, and hence the VL also goes on increasing over here. So that's all my friend. This is how the buck converter, so this is how the output voltage increases while the output current goes on decreasing over here. So for more technical session, please my dear friends, please like, share and subscribe to my YouTube channel. Thank you.